All right, so let's go ahead and share the screen, and here we go. Hopefully, should have you guys join this and see if you see it or not. Okay, perfect. I want to solve this equation here, y equals sine of x, y equals cosine of x, and x equals square root of 2. So we're going to find that bounded region there. And to do that in GeoGebra, um, let me move this down. Okay. So I'm going to shut off all of these because it might be distracting. And I'm going to do, I think it was sine of x and cosine of x, I feel. And then x equals pi over 2. Okay. So if we look at the graph of these, let me make sure I got everything right. Sine of x, cosine of x, and x equals pi over 2. So if I'm looking at this, right, the shaded region as I come along, this orange curve is the sine of x, and the magenta, I call it lilac because that was a color I heard earlier today, color there. So look, they meet right here at whatever this intersection point is, and they go from that value to pi over 2. So the first thing I need to do is figure out, okay, what is the intersection value? I need that because that's going to be my lower limit of integration. Okay, so to do that, I already know from the unit circle, but sine of x minus cosine of x, where does that equal 0? It equals 0 right there. To see how those correspond to each other, right? And that's at that value there. And so I can make this, I can find a root and sine of x minus cosine of x. And so there goes, that gives me the x value there. I don't have to do it that way, but if I wanted an exact, this happens to be pi over 4, if you see that those are the same value. Does that make sense? On the unit circle, it's where the x and y values are the same on the unit circle. So it's at pi over 4 for a sort of exact value, but we'll go with that. Okay. And so that's going to be my lower limit of integration. And so I'm going to go from the integral, and I have my upper function. So if I'm looking at the curve here, remember the orange one is the sine function right here is the upper curve on the interval from pi over 4 to pi over 2. Sine of x is the top function, and the bottom function is the cosine of x. So I'm going to have h minus p. That's going to give me the difference of those two. And then I'm going to go from the x coordinate of a to pi over 2, which is equation 3. I'll just do pi over 2 because it didn't seem like that. Okay. So there is the region of interest. And so the bounded area there comes out to be 0.4142, blah, 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 blah. Now, these are exact values, and so I can actually do that integral in a little bit more exact route. If I come down here to, if I hit the little drop-down menu and go to CAS, it stands for Computer Algebra System. So I can click on that, and I can do exactly the same thing here. Computer Algebra System is more exact in terms of giving you results that look like algebra. So we're going to do sine of x. Ooh. We're going to do cosine of x. Ooh. And then I'll just put it in here, pi over, yeah, sure, pi over 2. And then x equals pi over 4. So those are limits of integration. And so I'm going to do the integral. Here I'm going to do sine of x minus cosine of x. And I'm going to do that between pi over 4 and comma pi over 2. Okay, and so the exact value there is the square root of 2 minus 1. And if I do that approximately, you should see I get that 4142, which is what we got back here in the graphing version. So typically the way that these GeoGebra handles it in the graphing session is it does a numerical integration. So it won't give you really nice numeric or really nice closed form values like including pi's and stuff like that. It'll give you these decimal approximations. Again, because it's integrating it numerically. So if you want to know if there's an exact value for it, try doing the integration under the computer algebra or the CAS output. And if there is a nice closed form that GeoGebra can handle, it will output it in. And by closed form, what I mean is this, like a square root of 2 minus 1 instead of that 0.4142. Okay. All right. I know it's pretty fast, but you just made a video for this, so hopefully that makes a little bit more sense on how to solve that problem. And now what we'll do is we'll do it by hand and verify it's the same.